Hello guys. In this video, we are going to solve this two sum question. And so there are multiple two sum question, and this one can be solved in multiple ways. For example, if I don't know if any of you have previously seen the very common two sum problem. That problem is solved using a map. Basically, we use a map, and then we store indices over there, indices on one side. We'll come over here later. So we are asked to keep return two indices added by one that add up to the target, and so which is fairly simple. So if this is 0, this is 1, and added by 1 is 0 plus 1, and 1 plus 1, and which is our answer. Basically 1 and 2 is our answer. And so the let's discuss how we can solve it. First is we can use object, right? We can use object to store the target that we're looking for. This object can have a target and then the indices of the current element that forms the target. Basically, this is what I mean. So if we are at this position, if we are at this position, right, then calculation is target minus 2. So we will be looking for what? Target is 9. Target is 9. 9 minus 2. 2 is basically 7. So this is what we'll do. Since we'll be looking in this object, we'll do 7 as a key because we'll be looking for it. And then the indices will be current indices, which is 0, right? And let's say by after certain iteration, we reach to this 7. So we know we have 7 and we have the current indices at 0, 1 position. We know the value. This two adds up. So this is one way to solve it, right? And another way to solve it is basically you implement two for loop, and then you start from this. uh, let's say you have one of your pointer here I, and then another pointer starts at somewhere at z, and then you compare one element with all the other elements. But the time complexity is of n square over there. And with this, right, if you create an object, we are given a constraint that your solution must use only a constant extra constant space. So that means we are not allowed to create any array or map. So our hash map won't work in this case. So let's see what will work. Since we are given an array and we need to find two pointer in this array, right? We need to find two pointer in this array which points to a valid solution. And what is guaranteed is we have exactly one solution all the time. So for example, here the answer is 0 and 1 added by 1, right? So here our solution is 1 added by 1. So basically, we need to, if we can find this 0 and 1, we know our answer. So let's see what's the basic of two pointer, right? What's the code to implement two pointer? Basically, you have a left and then you have a right. And then what do? You until your left is less than right, meaning you have your left starting at the array, and then you have your right at the end of the array. And what you do is, since this array is in sorted order, and shrink this window. Either you move your left inward or your right inward. Both ways you are going to shrink your window. So here's what I'm going to do. And so, okay, let's here, right? And what are you going to do? We will say, we will compute our calculation. So let's say calculation equals to number at left plus number at right. And if this calculation, right, if calculation is equals to target, then we return the what do we return? Left plus 1, right plus 1, right? Why not right plus 1 comma left plus 1? Because see, the answer is in also like a non-decreasing order, which means it's an increasing order, kind of increasing order. So if this is the case, else if what I'm going to do, if the calculation is less than the target, then what we know is we need to have our calculation more than what we currently evaluating, right? So that means our left, that is looking at the smaller number. For example, here left starts here and right starts here, right? If we are adding this two number and getting a smaller value, that means our left needs to move further right, and then this is how we're going to go about it. And but if we need a smaller number, then this is what we're going to do. We're going to bring our right to the further left. So this way we can pick either a greater number or a smaller number. Calculation is less than the target, then we need to step up. That means our left goes for the right, else our right goes for the left. And this is the architecture, and this literally solves our problem. Just copy it, and our left starts at 0, right starts at numbers dot length. Okay, since we are accessing the index, we need to do -1 here. And calculation da 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 da, and then make it a little bit nice, like this. And so if calculation is equal, we return our answer. Else, calculation is smaller than the target, we step up our calculation. Otherwise, step down our calculation. Now let's see. And then we also need to. Okay, this is what we need to. Finger cross. Else if else if what is wrong? Or calculation is not defined. Okay, nice. This is how it works. And I am not being able to click on the submit button. Okay. There's a little bug on the surface. Okay. And this beats 100% of the solution on complexity. So that is, my friend, how you are going to implement this to some 32 pointer technique. And that has been my pleasure. Thank you.